On my first task, that is supervised machine learning. In order to do it, I have created a separate environment. Let's go to the Anaconda prompt first, and as you can see, I am going to activate my environment, which is named test. You can create new environment with create conda command, create environment command, conda create environment, that is. And as you can see, my environment is now activated. I am currently in this environment named test. What I'm gonna do now is that I'm gonna copy the path of my folders and change directory. After changing the directory, I'm going to open my Jupyter notebook here. As you can see, the Jupyter notebook is now open, and this is my first task 1, linear regression, which is an IPYNB file. I'm going to open it. Okay. Now, as I said earlier, it is prediction using supervised machine learning. Simple linear regression algorithm is used in this task. In this regression task, we will predict the percentage of marks that a student is expected to score based upon the number of hours they study. That is how much a person has studies and what is the output of the person. Is he getting a good output or bad output? Or what is the relationship between the both variables we are going to see. This is a simple linear regression task as it involves just two variables. I have named myself, given the author name. You can give it, I have used 3 has, and it's a markdown column, so it's not a code. Now I am importing the libraries, pandas as pd, numpy as np, seaborn as sns, matplotlib.pyplot for plotting as plt, and then from sklearn linear model I am importing the linear regression, which I'll be using to create the model. Now, first of all, we are going to read the data from the given link. The link was given in the slides, that task slides that were provided to us by the Spark Foundation. I have put it in a variable URL, and I am using pandas dot read csv and giving it the URL to it and storing it in the variable df. I am now printing data imported successfully. Then we are seeing the head of the data, that is the first 5 rows of the data. I can also see first 10 rows if I write here 10. Okay, I haven't run all the cells, so that is why it is giving me the error. As you can see, it has run, and now it is showing first 10 cells, that is 0 to 9. Now I'm checking here the df.tail, that is the last rows of the data. It is the information that how many values are null. As you can see, there are 25 not null values, non-null values, and 25 here. And the R's are in the float manner, and the scores are given in the integer format. Now I am using here df.describe. What describe does is that it gives us the total count of the rows and mean, what is the mean, that is average, standard deviation, minimum hours that are present in the particular column, minimum scores for 25, 50, 75 percentile, and maximum. Checking the missing values, I have used df.isnull.sum. As you can see, there is no missing value in this data frame. Now I'm going to plot a relation between R's and scores. What I have used here, I have used a scatter plot here, that is plot.figure fig size. This is the width of the graph, and this is 5 is the height of the graph. So if I increase it by 12, you can see the graph will increase. The width of the graph will increase. My x level here is R studied, and my y level here is the scores, and font size I have given both to 20. The title I have given R studied versus score. As you can see that from the scatter plot, it can be concluded that the R studied and the scores have positive linear relationship. That is, if one variable is increasing, the other is increasing with it also. Okay, and this is the scatter plot. This is the main line, which is plotting the plot here, the graph here. I have given it df.rs, which is the x-axis, dfrs, and df.scores, which is the y-axis, and color I'm giving magenta, and the markers are x. I can also change the, see, I have changed these to circles, but I prefer x. Now from here on, what I am going to do is that I am going to see, this is our data frame. I am going to split it. The R's are independent features. They are not dependent on anything, but the scores are dependent on the R's. So that is why what I am going to do, I am taking df.ilog. This format, this is the ilog format. This is the rows, from how many rows I want. And if I am, the starting here will be the row start. This tells us where the row start, and here we write the row end. As you can see, I have written nothing on it, which means I want all rows and column -1. That is, I am leaving the last column. What is the last column? This is the last column. I am leaving it, and I am only you can say I am only taking the first column. You can see 2.5, 5.1, 2 point, there it is, 2.5, 5.1, 3.2. I have taken the first column. By -1, I am leaving the last column, and I am taking dot values in, that is the x will be a independent feature. Now I am printing x here. Similarly, I have taken y. This, there I have used +1. Why +1? Because I am taking the first column. Why it is the first column? I can tell you. See, according to compiler, this is our 0th column, and this is our first column. So I am now taking this column. Here you can see I have taken only one. There is no column here. I am telling the compiler that okay, I want all rows and the first column, that is the which comes after the ours, that is our scores, and I have printed this. Now I am splitting the data frame into train and test sets. I have imported train test split from sklearn.model selection. Xtrain, ytrain, xtest and ytest are being calculated here. As you can see, I am using random state 101. If you use random state 101, your random variables will be same at every time. I am taking test size equal to 20%. That is 80% of our data is training data and 20% of our data is the test data. Now I am going to train the model. I am initiating the instance. Remember, I have imported the linear regression from sklearn.linear model. I am using it here. I am creating an instance, and then I am calling the fit function, and I am training or fitting the data to train. So xtrain and ytrain I have given. As you can see, I am printing the training is now successfully completed. This is the slope of our line which will be selected. The slope, you can remember this formula, y is equal to mx plus c. It is the formula of a line. So you can see here our m is this, and intercept, and this c value is this. And now I am calculating the whole line. You can say to plot this line, I am applying the same formula has been applied here. You can see coefficient multiplied by xtrain, which will be our training data points, and plus intercept. I am printing it here. Now plotting regression line on the train data. As you can see, it's the figure size is given, and scatter xtrain, ytrain, color magenta, same thing that I have done earlier. Then I am going to plot xtrain. Y I am giving this y has been given here to plot, and color is the blue. As you can see, this is our regression line on train test, which is quite good looking. And now we are going to predict the scores for the test data. I am going to use the function dot predict, and I am giving the test. As you can see, I trained the model on training data, and now I am testing the model. And these are the answers or the predictions that are given to me by compiler. And now you can see I'm plotting regression line with the test data, as these were the same points that I got, and it's the same every time. It's the same code that I have used earlier and earlier. I am creating another data frame, actual versus bread. In this data frame, I am just analyzing how much variation is there. As you can see, if the value is 30, it's around a variation of 4. It's 85, it has a large variation. Here it is also a variation of 4 and 5. Here is a variation of 5. Here's a large variation, and you can see the result is varying, but still it is able to tell us if the person is studying harder, he is getting good results. Accuracy of the model, R2, I am using R2 score from the matrix, and you can see we are getting the 0.937. Now what is 0.937? The R square measures the strength of the relationship between your linear model and the dependent variables on a scale of 0 to 100%. Our model is performing well at 93%. So if you multiply it by 100, obviously it's 93%. Now what are the errors? I have calculated the errors: mean squared error, root mean square, and mean absolute error here. Nothing fancy. And what will be the question was asked at the end of the slide, what will be the predicted score if a student studies for 9.25 hours per day? And I am storing in the answer in this variable lr.predict, and I am giving this value, and the predicted score for the student studying for 9.25 hours per day is the answer, and the answer is he will be able to score around 92 marks. It will not be exactly 92. Remember, it's a machine learning model. There may be a mistake, and its data frame is a very small data frame. So was my first task that was given by the SPARK Foundation. Thank you very much.